All right, today we're looking at linear, quadratic, and exponential models. And our first concept is we're going to be graphing data in order to choose our best model. Okay, and when I mean model, I kind of mean line of best fit or the closest equation that we can come up with or function. So really we got to think back to our three different types that we've learned about so far. We have our linear, okay, our y equals mx plus b, which gives us a straight line. Okay, the slope can change, but no matter what, the line will continue going in both directions infinitely, and it will always remain straight. Okay, quadratic forms our parabola. All right, so if you're looking at a quadratic, if you can find the vertex, right, that's going to be the easiest way to tell that you're looking at a quadratic, because sometimes, especially at far distant points, these our values will look very close to linear. Okay, and then exponential. An exponential function is similar to a quadratic in that at extreme distances it'll look very linear, it'll look very straight, but we're again looking for that bend. Okay, whereas a quadratic function kind of is a 180-degree bend, a exponential function is usually more like a 90-degree bend. Okay, so that's basically what we're doing is we are graphing values and then looking to see what kind of model will best fit them. We don't have to find the equation, we don't have to find any specific points on that graph. We just have to say, what is my best model going to look like? How can I best represent this data using one of these three equations? Okay, so plug in our values. We've got our table, x and y, -1, 4, and 0, 8, 1, 10, and then back down to 2, 8, and we can see we've got our curve, right? It's going to make kind of a 90-degree bend. It's probably going to come down on this side as well and go something like that. And we can see that this is going to look most closely resemble a quadratic equation. So that would be my best model for this data set. Okay, that's straightforward.